Analysis of variance with two factors having no replications. It means two-factor ANOVA without replication. Sometimes we need to perform ANOVA when we have two factors but we don't have any replications. For example, we have RCBD, randomized complete block design. When we have 4 blocks having some data and every block has some treatments. So for treatment, the replications are taken from the blocks, and for blocks, replications are taken from the treatments, vice versa. So this is sometimes we call two-factor ANOVA without replication. We can easily perform this from Excel. At the same time, we can also perform from SPSS. So today I will show you how to perform this in SPSS. This is the data that we have. So at first we have to open a file in SPSS. In SPSS we will open a new data sheet. New data sheet, which is a blank data. So in this blank data we have to copy and paste the data from Excel. So this is a block 1 and block 2 and block 3. So every block, at first we have to create some column like a variable. Click the variable name, double click the name on the variable, or you can select variable view and data view. So double click variable name. So first variable should be the treatment, and second variable should be block, and third variable should be the response. So now go to the data view. So we will have the treatment, block and response. As we already know, how many treatments we have? 1, 2, 3, 4, 5. So we will type the treatment 1, 2, 3, 4, 5. So in this case we have how many blocks? 1, 2, 3, 4. So we type block 1, on, and on. So we have 4 blocks. So type 2, 2, 2, 2, and 2, because it's a 5 times of treatment. Copy, treatment and paste. So we have another 2 blocks we have to type. So you can type 3, 3, 3, 3 and 3, and again paste the treatment number. So we have 4 blocks. So we have to type it 4 times in SPSS data. Another one, 4, 4, 4, 4, 4, and again paste the treatments. So we have 5 treatments, 4 blocks, and we have the data. So we can easily copy paste the data. For example, the first block, select the first column, copy and paste here. Second column should be paste in the next row, block. Third column is the third block. And the last one, last block. Alright, so we have treatment, we have block, and we have response. So we can easily perform the statistical test using this. So if you want to change the level of treatment 1 and block 1 as a particular treatment name, then you have to assign a text, because these are the text variable. So go to the variable view and click the value. So we know the treatment has 1, 2, 3, 4, 5. Click these 3 dots here. I should magnify the screen. Yes. So click these 3 dots here. After you get this, so type, I know it is 1, 2, 3, 4, 5. So 1 is a treatment 1. Treatment 1. Add 2 for treatment 2. I can copy this treatment for multiple use. 3 and paste treatment 3. Add 4 treatment 4. Add 5 treatment 5 and add. So now we got renamed all the treatments. Now we can also rename the blocks. Click here. Say we have 1, 2, 3, 4. 1 is a block 1. Copy the block for next use. 2 for block 2. 3 for block 3. And we have 4 blocks. Add. Now it's the block part. So we go to magnify normal and we go to data view. So it's now changed to the text version of this data. Like if we click here, then we can see the numeric. When you click when you click this button, then you will see the treatment 1 and treatment 2, 1, 2, 3, 4, everything is sorted as a text, and when you click, then as a number. So basically the treatment and block, these are non-numerical variable, because these are text variable, only the name, the treatment name and block name, nothing to do with the mathematics, but only mathematics is here, the response. So every calculation will be made based on this column. The others will be treated as a text value. So we can choose which type you want. Either you can do numeric or the non-numeric. So non-numeric is better to understand what is meant by treatment 1, or because 1, 2, 3, 4 is not easy way to compare. But if we know, if we see the treatment 1, 2, 3, 4, then it's very easy to identify by the users. So let's go. From now we will start analysis. Now we have already formatted the data from two-factor without replication. The data was in this way, and in SPSS it should be in this way. Treatment 1 is the first column, block is the second column, and response should be the third column. So response is the data that we actually measure. It can be anything depending on the experiment. So we start how to perform the analysis of variance ANOVA using this SPSS. Analyze, compare means, and univariate. So we go to the magnifier. So analyze, compare means, no, generalize linear model and univariate. So this is the way normally we do this ANOVA. Click ANOVA. you have this menu here, the treatment, block and response. So we can see that something wrong with the block, treatment, everything is in the same version. We can see what happens if we use this as it is. If something is wrong, then we have to use the scale version of the block and response. Let's go for it to learn it. What happens if we use in the same scale variable? We make a response and no, I'm wrong. The response should be as a dependent variable. So that's why to make mistake, to avoid mistake, we need to make the type of the data. We close it, we go back to the variable view, and on the right side you see the data type, the measure. Everything was in scale. So as we are sure that the response, the last variable is the response variable, this one is a numeric and other things are non-numeric. This is numeric, this one is numeric, and this is also numeric, but the scale is different because 1, 2, 3, 4 is numeric, and we will change the scale. The last one should be definitely a scale, and the second one should be ordinal or nominal, because this is a name. Treatment is simply a name, block is simply a name, it is nominal. So it's always better to make this scale to the right way that it should be. So I think it's now ready to analyze. So go to the data view and try again the GLM univariate. So this is the most important part of performing ANOVA, that you click the right menu, GLM and univariate. This is the menu that we need to use. Click here, and in this case you will see that the items looks different. So response is a scale that is measured in the numeric scale, should be in the dependent variable. So dependent variable means this measure depends on the treatment, which is a nominal value. It means it has a name, treatment 1, treatment 2, block 1, block 2. Now it looks fine. So model, click the model. In this model you can do full factorial or you can do custom. Normally custom is better. Click custom. At first click the treatment and move it to the right side. Click here. It should be on the model part. Block, same way. Because we don't know where there is a variation, we can get variation in both, or we can variation in one or another one, maybe no variation. So we will check it. So it should be both, should be on the right side. Interaction. In this case we should follow the main effect, because we will follow only the treatment effect, only the block effect. But if somebody is interested when other type of parameter is used, then interaction effect, the source of variation will be 3: treatment, block and interaction. But if we do the main effect, then it will be only 2 source of variation. After that we click OK. But before that we should click here, uncheck this box, include intercept model, we don't need it, and continue. After that we click OK. So we will get this result in SPSS output. This is the output. Make it zoom. So this is the output. Let me explain this model. This is a significant value that we get. Significance value should be normally smaller. This is very small. The model indicates the 99.9% significant. So if you deduct this value from 1, then it will be 99.9%. for model. For treatment, the same, 99.9% significant. If you go for block, then 0.08. Normally this is a p-value. Significant value is normally the p-value. So in this case the p-value is 0.08. So if you deduct this value from 1, then 1 minus 0.087, it means 92%. 91.3% is, so it means it is not significant. So block effect is not significant, treatment effect is significant. So this is the conclusion that we can draw from the two-factor ANOVA with replication, without replication. Now if we make an interaction effect, then what happens? Go to the data and we will go analyze, compare mean, generalized linear model and univariate. Then we select the model and we select interaction effect. So in this time we choose main effect, before already done, and now interaction effect. Click continue and OK. Now because there is no replication, so interaction effect is not printed here. So in other case of data, if you want to see interaction effect when the different kinds of data, in the next video I will show you the interaction effect with different kinds of data, like two-factor ANOVA with replication. When we have with replication, then we have this kind of interaction effect. Then I will show you this in the next lecture. So until this, we learn how to calculate the analysis of variance. This is the analysis of variance of a model having two-factor. One is the treatment and one is block, and this two-factor has no replication. In this case, we have to follow this kind of ANOVA, and how to create the data from Excel to SPSS, and how to analyze this. So until this we learn. But one thing is important to know. We know the significant difference between the treatment effect is significantly different. It means the treatment 1 and 2 and 3, they are significantly different. But if I ask a question, which treatment is the best, how to know? Then we need a post-hoc test. We need a post-hoc test. So how to do it? In SPSS, then go to analyze, generalized linear model, univariate, then click post-hoc. So we need to click here as a post-hoc test. Click here to know exactly which treatment is the best. Then we need a post-hoc test. After you click post-hoc, because we know the block effect is not significant, but treatment effect is significant, so we put only the treatment on the right side for post-hoc test. So click here, Tukey test and Duncan test. Maybe these two. All of these are, you can choose anyone that you want. So for this case, I will choose only these two, or only one. maybe LSD or Tukey, or these are the things we can try. So click this and click continue and OK. Now we will see after post-hoc test. This is a post-hoc test, and we have to follow the homogeneous subset. Click here, then this is the homogeneous subset that we got. In this homogeneous subset, what we see is the treatment, and this is a Tukey test result. We know that we have only 5 treatments. So among the 5 treatments, we already know that treatment effect is significant, but Tukey test result indicates that there are 2 subsets. Subset number 1 has treatment 2, 1 and 3, and subset number 2 is another homogeneous group. Homogeneous means there is no difference among or within the subset, but it is different between the subset. So treatment 4 has the highest average value, and treatment 5 has the second highest average value, and treatment 3, 1, 2 has a different average value. So we can say treatment 4 and 5 are significantly different than treatment 3, 1 and 2. So you can even assign later the treatment 2 as treatment 4 as A, treatment 5 as A, treatment 3 as B, treatment 1 as B, and treatment 2 as B. So we have basically 2 groups, A and B. So A group includes the treatment 4 and B group include treatment 3, 1 and 2. So basically subset 1 and subset 2. So this is the way how to perform post-hoc test, or which is also called multiple comparison test using SPSS from the RCBD dataset. This is also called homogeneous subset. So we learned how to perform ANOVA and how to perform a post-hoc test using a data which has a 2-factor and which has no replication. Thank you very much.